In today's session, we will start module 4. So far in module 2 and 3, we have studied electrostatics and magnetostatics. That is, we have studied about electric field intensity as well as magnetic field intensity. And then towards the end of the third module, we came across a time varying field. Till now, we were talking about only static field. Now, then we studied about time varying field, and then we understood how the Maxwell's equations. You know that there are 4 Maxwell's equations for a static field as well as a time varying field, and we understood how they are behaving, like what are the changes that are coming in the equation. Not only the equation, but why physically, what does that mean, and all these things we have seen. So what does that mean, changing with respect to time? All these things we have already seen. So now we will study about electromagnetic field, so which is a combination. So in my very first class, I have given you how the subject is going. So there you might be remembering. So we will study introduction, electrostatic, magnetostatics. Then we will study about electromagnetic field. Like towards the end of third module itself, we have studied time varying field. There we studied about Faraday's law and all. So now we study about a bit more in detail about electromagnetic waves. So in third module, we didn't study about waves, right? So now we will study about electromagnetic waves and how they are being propagated. Okay. So here we have a figure here. So I will explain this figure on the go. So directly, I'm not going to take you to the figure. So you understand that electromagnetic field is a combination of electric field and a magnetic field. So this fourth module aim, the objective is, like, we need to explain this electromagnetic wave propagation by using the Maxwell's equation. That's why I told you lecture number 37 is very important, because there we have seen all the 4 Maxwell's equations, both in time varying, static, and so here what we need is time varying only. So electromagnetic field, in this module, what we are trying to understand by using Maxwell's equation that how the wave is generated, how the electromagnetic wave is generated and propagated. Propagated means how it is traveling. So whether there is any attenuation, or whether the wave we are generating, that same amplitude wave we are getting at the receiving end. All these things we need to analyze. So first of all, we will go with some basic things to make your understanding. So we can write, like I told you, like electromagnetic field is a combination of electric and magnetic field. So we will first of all, we will see some basic things. We have seen that already. We have seen, and you might have studied in your machines, DC machines and transformers. Basically, in transformers, you might have studied that a magnetic field is generated by a time varying field, right? Some important points that you should know. A magnetic field is generated by a time varying field. Sorry, a time varying current. So if the current is, means a magnetic field will be generated. So a magnetic field will be generated by a time varying current. So time varying current means it will be, if you have di by dt, that is equal to, time varying current means di by dt. So I is equal to q by t. Then you can also write d square q by dt. So that should not be equal to 0. So it should be a time varying current. So a magnetic field is generated. So a time varying magnetic field is required. So a time varying magnetic field is produced. So what is that law called? A time varying magnetic field produced in Faraday's law. We have already seen. Like the conductor will be there, a flux is changing, then an EMF will be generated. That is E is equal to N into d phi by dt. So we are coming to that. A time varying current produces a time varying magnetic field. So a time varying magnetic field in turn will produce a space varying electric field. So that's del cross E and during when we were studying about Faraday's law, we wrote an equation del cross E. So what does del cross mean? Del cross actually means the curl. del cross it is curl. So curl means it's a space varying electric field. So time varying magnetic field will generate a space varying electric field. So you have a space varying electric field. The time varying electric field will again generate a space varying magnetic field. So this process will go on like that. So that's what actually happening. A time varying current will produce a magnetic field. A magnetic field will produce an electric field, and a time varying electric field will again produce a magnetic field. So this phenomenon is going like that, and this process in turn produce what we call a wave, that is an electromagnetic wave. So this is actually a rough figure of an electromagnetic field. So here we have a electric field and magnetic field. So I already told you electromagnetic field is a combination of electric and magnetic field. So you can see that. So it will be in two different directions. So about the direction and all you can see later. So now you just understand that there will be an electric field and a magnetic field, and the combination of that will make you electromagnetic wave. So it is getting propagated in one direction. Maybe X or Y, so they haven't named it, so maybe it is Y only, or X, Y, Z according to what they have mentioned. So I'll write the third point also. The time varying magnetic field will generate a space varying electric field. The varying electric field will again generate a space varying magnetic field. Space varying magnetic field. And so on. And we will get a wave. So this is actually the very basic story. Okay, so that is how we get an. So basically, you understand that it is a combination of electric and magnetic field. I cannot simply tell you electromagnetic field is a combination of electric and magnetic field. So that doesn't make you understand anything. So what I'm telling is, you just think about Faraday's law. So Faraday's law means change in flux. But change in flux and change in magnetic field. So you should have that understanding. Okay, flux is changing means there is changing magnetic field. So change in current. So current is changing. Then that results in a change in magnetic field. Then that change in magnetic field will have a change in electric field, because there will be change in that curl will be there, del cross E. So that change in turn will again produce a change in magnetic field. So our change in magnetic field are EMF produce Faraday's law. So now we are not going to Faraday's law. So this combination of electric and magnetic field will result in an electromagnetic wave. So that's how electromagnetic wave is generated, just the theory. Okay, but your syllabus is actually starting with electromagnetic waves and Maxwell's equation. Directly, they're talking about the derivation only, but still I have given you the basic introduction. Now we will study about wave equation. So examination point of view, wave equation is very important. Wave equation. So now the main aim is to realize the wave equation by using the Maxwell's equations. So first of all, we'll start with the Faraday's law. So Faraday's law for a time varying field we know. So Faraday's law, we know that this equation del cross E is equal to minus dou B by dou T. You know that, and also B is equal to mu 0 into H. So these much things it's familiar for you. So where B is the magnetic flux density, H is the magnetic field. So we can combine these two equations and write del cross E is equal to minus mu naught into dou by dou T of H. So this is actually magnetic field intensity. And also we can write the electric field E. This electric field E will actually be a combination of a position vector as well as time. So where R is the position vector. So if you can remember the last figure we have seen, the electric field which we are telling, it has a position vector as well as it is time dependent. It is time dependent. Just see this figure. The electric field here, it has a position vector, right? With respect to origin, if you can write a position vector, as well as it is varying with respect to time. So same will be the case with electric field intensity. Okay, so now you understand. So Faraday's law, del cross is equal to minus dou B by dou T. So B is equal to mu naught into H, and del cross is equal to minus mu naught into dou H by dou T. So we got up to this equation. Now we will write Maxwell's Ampere law. So that's why I told you should know the basic equation. So Maxwell's Ampere law. Maxwell's Ampere law, what does that state? See, del cross H is equal to J plus dou D by dou T. So dou D by dou T and all we have added. And for a one thing I want to say, for a linear isotropic homogeneous material. So we are talking about a linear isotropic homogeneous material. So basically what does that mean? It is the vacuum of p space only. In most of your textbook, it is telling like vacuum of free space. You just study that only. But what does that mean? It is the linear isotropic homogeneous material. Okay, or you can say in free space. So what does that mean? Free space means, last class I told you, lecture number 37 has that information also. What does that free space means? Free space means there is no conduction current there, right? Free space means J, which is the conduction current, that J is equal to 0. And we consider region far away from the source. So J is equal to 0 means volume charge density rho B is also equal to 0. And also we can write D is equal to epsilon 0 into epsilon R into E, or you can also write epsilon into E. So that is the Ampere's law. So now we have two equations, right? First equation is del cross E is equal to minus mu naught into dou H by dt. And second equation is del cross H. That is actually the modified Ampere's law. First one is the Faraday's law. And second is a modified Ampere's law. So epsilon E, I am substituting for D. So that's how it is getting updated. Epsilon E into dou E by dou T. So here we can see that in this case, electric field is varying with respect to space. So electric del cross H means curl. So this is what we call curl, right? So del cross H means it is a curl that we are taking. So del cross H is varying with respect to space, whereas that means electric field is varying with respect to space, and magnetic field intensity is varying with respect to time. That is in equation 1. Then in equation 2, the reverse. The magnetic field intensity is varying with respect to time, and here the electric field is varying with respect to varying with respect to space, and electric field with respect to time. So this is the same thing that I explained to you just before, the basics of electromagnetic wave. So that two things we have written by using the Maxwell's equation. So by using Maxwell's equation, we are explaining the propagation of electromagnetic waves. First of all, I told you the theory behind that, and now I have shown you by using Maxwell's two equations, like how the wave is getting propagated. Like space varying, then electric field, then that same magnetic field will be space varying, and that will give us the electric field. So like that, the combination of results. So now we have del cross E. So now we need to do some basic operations on this. So we have the equation del cross E is equal to minus mu naught into dou H by dou T. So taking the cross product on both sides, del cross E is equal to del cross minus mu naught into dou H by dou T is equal to minus mu naught into dou by dou T of del cross H. So it's, I guess it should be clear from the steps, del cross H. Then from equation 2, so I have written two equations, 1 and 2. From 2 we can write, del cross E is equal to minus mu naught into epsilon naught into dou square E by dou T square. So we have combined, we have brought in equation 2 here. Then by using vector identity, you might know this formula. We have already seen del cross E is equal to del of del dot T minus del square E. We have used this formula while studying scalar vector product and all we have studied. So by using a vector identity, we can write del dot E minus del square E is equal to minus mu naught epsilon naught into dou square E by dou T square. And we already know that del dot D is equal to rho V and D is equal to epsilon E. Then we can write del dot E is equal to rho V by epsilon 0, which is equal to, but rho V we have already seen. The value of rho V we have already seen is equal to 0 for free space. So the value of rho V is equal to 0 for free space. Rho V equal to 0, which in turn makes del dot E equal to 0. That means this particular term we can cancel out. I guess you understood. This term we can cancel out because del dot T is becoming 0. We brought in the rho V factor. Rho V is equal to 0 for for free space. Now the equation get updated to what is the new equation? So slowly we are arriving at the wave equation. So now the equation got updated to del square E is equal to mu 0 epsilon 0 into dou square E by dou T square. And here we can write mu naught epsilon C naught is equal to 1 by C square, where C is equal to velocity of light. So what we finally write? Del square E is equal to 1 by C square into dou square E by dou T square. So this is what we call the wave equation for free space. So this is the wave equation for electric field. So similarly, we can write for magnetic field also for electric field in free space. So this is the wave equation for electric field in free space. So in order to study the wave equation, we have used the Maxwell's equations. I will just show you wherever we have used the Maxwell equation. So del dot D is equal to rho V is a Maxwell equation. Then this is a Maxwell equation. This equation 1 and 2, they both are Maxwell's equations. So by using the Maxwell's equations, we have derived that we have studied how the wave is getting propagated. So first one is for free space. So after this, we will study for dielectric medium. For another medium, then like this only your subject is going. So we have written for electric field. So similarly, we can write for magnetic field also, it will be del square H is equal to mu 0 epsilon naught into dou square H by dou T square. Similarly, just same way you can write. Okay, so it's for electric field. So if you are asked to verify derived wave equation, means this is how you should do it. So if now we have talked about mu 0 epsilon 0 only. So if it is in another medium, like if in another medium, if it is not in free space, then C will be equal to 1 by root of mu 0 epsilon 0. Along with that, you will have mu r into epsilon r. So that permittivity and permeability also you need to consider. So that's only the main difference. And now for a dielectric medium, how it will vary, we will see. Okay. Same things only, but I will show you separately one by one so that it is easy for you. So now I will give you some basic informations regarding the medium. So actually what we are studying is the Maxwell's equations, that is propagation of electromagnetic wave. Propagation of electromagnetic wave. Propagation of electromagnetic wave to solve Maxwell's equation. To solve Maxwell's equation. So for that we are basically studying it in 4 different mediums. First one is free space. Free space means there will not be any charge. Sigma equal to 0. Epsilon is equal to epsilon 0. Mu is equal to mu naught. Then second, lossless dielectric medium. So lossless dielectric medium means sigma equal to 0. Epsilon is equal to epsilon r into epsilon naught. Mu is equal to mu naught into mu r. So this will be very important in all the upcoming portions. And sigma is very less than omega epsilon. We will see all these things. And third is lossy dielectric. Lossy dielectric means sigma not equal to 0. Epsilon is equal to epsilon 0 into epsilon r. And mu is equal to mu 0 into mu r. And fourth one is a good conductor. A good conductor means it will be sigma is equal to infinity, epsilon is equal to epsilon naught, mu is equal to mu naught into mu r, this into only, and sigma is very much greater than omega epsilon. So all these things are required when you study about, like in different medium, how the wave is propagating. So there we will study about propagation constant, attenuation constant, all these things in different mediums we need to study. That is gamma, beta, alpha, all these things. So when we study, and then we study about skin effect, skin depth and all. So by this our module will be completed. So this is a very easy module. So learn along with me, because you have your exam coming on 17th, right? Second series. So this 4th module, you learn along with me. It will be very easy. Don't keep it for last. Okay, 3rd and 4th. So we are planning for 3rd and 4th module. Remaining of the second portion also will be there. I need to check with sir. So we will see.